Hi, I am Dr. Shahriar Hossain. Today I am going to explain some items regarding numeric operators in Java. In the previous videos of this lecture series that Dr. Monika Akbar and I taught, we discussed numeric data types like integers, double, and byte. We also discussed simple arithmetic operations like addition, subtraction, multiplication, and division. We'll describe more on how to use arithmetic operations using Java in this lecture. Java or most standard programming languages have five numeric or arithmetic operators: addition, subtraction, multiplication, division, and remainder. We already worked on addition, subtraction, multiplication, and division in another video. They are basic arithmetic operations, and I am sure everyone who is watching this video is familiar with them. What is not common is the remainder operation, which is represented by the percentage symbol. In Java, the percentage symbol does not have anything to do with percentage. After you divide a number by a divisor, you get a quotient, and then you have a remainder. The percent symbol or operator in Java will give you the remainder. For example, 14 remainder 4 is 2, because 4 times 3 is 12, and then you will have 2 remainder to reach 14. The remainder is computed by the remainder operator. Anyway, the remainder operation is not hugely common in day-to-day software development. You might need to use the remainder operation if you are working on projects that require implementation of mathematical equations. Let us talk about how to perform numeric or arithmetic operations in Java. You may recall from middle school how we did simplification of mathematical expressions. We used square brackets, curly braces, and parentheses in arithmetic expressions. In Java, the use of curly braces and square brackets is restricted. In arithmetic statements, we can only use parentheses. For example, in an expression like this one, we have to replace the opening and ending curly braces with opening and ending parentheses. Also, we cannot skip any operator when we write arithmetic statements. On paper, in this expression, we did not provide the multiplication symbols. When using Java, we must explicitly put the multiplication symbols. Another item I should mention is that whatever arithmetic statement you write, the result should be kept in a variable to be able to use it later. For example, if you have a double variable named res, then you can write res equals this whole arithmetic expression. Remember from the previous video lectures that the right side of the equals symbol is executed first. The equals symbol is called the assignment operator. Of course, in place of variables like a and b, Java will put the values in those variables before computing the arithmetic expression you have written in the right side of the assignment operator. After the right side of the assignment is operated, the computed value goes to the variable you have placed in the left side, which is res in this case. Let me quickly code the program. Notice that I initialized a to 1.0 and b to 2.0. For these values, I am doing the calculation on paper first. The simplified value is 27. The same way I did it on the paper, the Java virtual machine will do it for me using the computer's processor. That is, if I run the program I have written, the computer will evaluate the arithmetic expression we have in the right side of the assignment operator of the res variable. If I compile and run the program, I will be able to check if the program prints 27 as expected. After compiling and running the program, we see that 27 is printed on the terminal. This demonstrates that whatever we did on paper is actually replicated here using the program. We have written a program that can compute the mathematical expression. In an ideal case, we will not hard code the initial values like what we did here in our code. We know how to change the code to ask the user for the values of the variables we have. I will now change the code. I will use a scanner object that I will use to get the user input for A and B. After I do that, my code will ask the user for each of the two numbers. The program will take the first number and put it in A. It will take the second number and put it in B. Let us save the file, compile it, and run the program. The program is asking for the first number. The user enters 1. It is asking for the second number. The user enters 2. The computer states that the calculated value is 27. We can run the program again and again and find the calculated value for any two numbers. You can write a program to compute the area of a circle, or a rectangle, or a trapezoid, or practically anything as long as you have the arithmetic expression for the problem you are trying to solve. Let us go over another program. We are writing a program that is able to compute the area of a circle. Remember from geometry that the area of a circle is pi times r square. Pi is a constant. That means the value of pi never changes. The value is quite long, but in this program, we'll keep only a few digits after the decimal point. We will use pi equals 3.14159. Notice that the only variable you have here for the mathematical expression is r, which is the radius of the circle. Therefore, we will ask the user to provide the radius. After the user provides the radius, all we have to do is to compute pi times radius square. The radius is stored in the variable r. Therefore, we can write r times r for radius square. My arithmetic expression becomes 3.14159 times r times r. We will put the computed value of this expression in a variable named area. Therefore, we will print the area. Let us save the file, compile it, and run the code. The user enters a radius of 2.0. The program computes the area and then prints the area of the circle on the terminal. The user can run the program again and again to get the areas of circles of different radii. I will go over one more program right now. Suppose you have this following expression. The expression in a Java code will be. Notice that there are two variables x and y. Therefore, we will ask the user for two numbers, x and y. These two numbers will be kept in two variables, named x and y. We will make x and y double numbers. We'll keep another variable named result, which will hold the computed result. Let us do the coding in fast forward mode. Please pause the video if you are coding it. I will provide the code in the website computingforall.com. However, I recommend that you type it yourself. I feel that when you type a program yourself, you build a foundational understanding about the program. Let us save the file, compile it, and run it. The program asks for the first number and the second number. The program computes the expression for the two given numbers and prints the computed value. We will provide exercises regarding today's video on our website, computingforall.com. As I said before, one cannot learn to ride a bike or to swim by watching videos or by reading books. Similar to that, one cannot become skilled in programming just by watching videos or just by reading books. Please practice, practice, and practice to make sure that you develop a strong programming skill over time. Thank you.